Let's go down the page to number 6. No, let's do number 5 first. Let's do number 5. Y equals 4x minus 9. Y equals x minus 3. So everyone try this one now. Did I turn this on? Try number 5 now. Check on the board to see if you got the first part right. Oh, but that's a positive 4x. If you add 4x, that just gives you 8x, huh? Right. If you have to do it to both sides, right? So you can't just add 4x to one side, right? So if I add 4x here and I add 4x here, this gives me 8x now minus 9. 4x and 4x? You have to put minus. You wanted to subtract 4x, didn't you? Yeah. Now, the reason that I subtracted x is because this would give me a positive here. But we can subtract 4x from both sides. That gives me negative 9 equals, this gives me negative 3x minus 3. Then I add 3 to both sides. Negative 6 equals negative 3x. And then divide by negative 3, and I get 2 equals x.
Both ways work, it's just the other direction.
Or x equals 2. So, after you went up there, it was that one loud boom.
I heard that, but you know what? It's not upstairs. I was in there talking. I heard it too. She said that she didn't hear it as well. I'm thinking, don't quote me on it, but I'm trying to see. It has some guys behind that dumpster hitting on the thing.
Oh, but no, it wasn't that.
It wasn't that. So you heard it too.
It comes from like right here.
You think it came from right here?
I was going to go to the next door, but I wanted
Yeah.
to come down and talk with you and see, did you hear it too? Because
Yeah.
I
I heard that one. It was different, though, than the ones that we'd been hearing. Boom,
I
boom,
heard it too
boom,
when I
boom.
was in her place. And
Yeah.
I asked, I said, wait a minute. I said, no. It's
Yeah.
from somewhere
But
else.
that was a different sound. I just thought, I told them, I said, oh my goodness, hope he didn't throw something at her.
Come to help me?
Yes.
You know what? It is the door next to
That could
bubble
be.
next door to them.
Yeah.
Either they must be putting something up, I'm thinking, but
Yeah.
I was in a place.
Yeah. But what I'm saying is that one was very different than the ones we were hearing.
Because I heard it upstairs too.
Yeah. But that was different than the ones we were hearing before. The other ones were rhythmic. Boom, 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 boom. That's exactly. That's what it sounds like. That's odd.
Yeah, pick up some heavy weight and it's dropped.
That's exactly what it sounds like. Yeah. But it sounds like they're doing it with rhythm. Yeah. Okay, crew. So let's look up here. So we all agree then, Austin, we all agree that x equals 2? Okay. Now, we take either one of these equations. This one's easier, so I'm going to use this one. I'm going to plug in -2 for x. I'm going to find out that y is -5. So now, 2, -5. Now, if I plug in the solution, 2, -5 is a solution for this equation, and 2, -5 is a solution for this equation. It is the only solution that they have in common.
How did you get 5?
-2 minus 3.
Oh, okay. I thought you did something exactly.
No, just -2 minus 3.
I'm learning.
Now, let's take a look right here. Let's take a look right here. I took these two equations, y equals 4x minus 9 and y equals x minus 3. Now, I know they're both the same y. I don't know what the y is, but I know they're both the same y. So if y equals this, then I can replace this y with this. So I substituted this y for what this y equals. That's substitution. Now let's take a look at number 6. Say it again.
For the y part?
What's -2 minus 3?
I mean, how did you get the -2?
Oh. Oh, hello. Thank you. Thank you, Cash. I put a negative in. This is 2 minus 3 is -1. -1. Thank you for catching that.
Why is it -1?
What is 2 minus 3? Do you see what I did? When I plugged in x equals 2, I put -2 by accident. But that was x equals 2. Thank you very much for catching that, Cash. Now, let's take a look at the next one, number 6. With number 6, we have 4x plus 2y. 4x plus 2y equals 10. And x minus y equals 13. Now, what I'm going to do is, I'm first going to take this one, and I'm going to get y alone. Let me do it right here. I'm going to get x alone. I'm going to take my first equation, x minus y equals 13, and I'm going to get x alone. I'm going to add y to both sides. That gives me x equals y plus 13, or 13 plus y. It doesn't matter. Does everyone understand that step? I'm going to get one of my variables alone. In one equation, it doesn't matter which one, in one equation, get a variable alone. That's step 1. Does everybody understand that step? Now, I'm going to go back to my other equation, 4x plus 2y equals 10. And in place of x, I'm going to put y plus 13. Does that make sense, Ashlyn? I'm going to substitute for x, I'm going to substitute y plus 13. Plus 2y equals 10. So I'm going to substitute the variable in the second equation with the answer to the first equation. Here's the answer to the first equation. Y'all are playing around. When I turn around and I see y'all laughing, I know you're not paying attention. You're going to substitute. Am I talking to you? You must be the one not paying attention then. Okay, so I'm going to substitute this variable. Maxwell. I know. I'm going to substitute the variable in the second equation with the answer to the first equation. Does that make sense?
Not really.
What part's giving you trouble? Here's my second equation. Okay? So first I took this equation and I got one of my variables alone. That's step number one. One equation, in one equation, get a variable alone. I should put in one equation. In one equation, get a variable alone. So I did that right here, right? Now I take my, substitute the variable in the second equation. So here's my second equation, right? I'm going to substitute the variable in the second equation with the answer from the first equation.
Okay,
so x equals this, right?
So you replace x with y plus 13.
Exactly.
And then how would you go?
Well, I didn't do that yet. Okay? Do you understand that step? Okay, now take a look at this. How many variables, Ashlyn, do I have in this equation? How many types of variables? Only y, huh? When I have one variable, I can solve it. So I'm going to solve for y now. Sullivan, what would I do first when I'm solving?
4 times y would equal 4y.
Very good.
And then 4 times 13 would equal 52.
Yeah, and then plus 2y. The first thing I do is distribute.
And then you got to get rid of.
Collect my like terms. So then I distribute. Then I collect my like terms. Does that make sense?
Yes, ma'am.
4y and 2y is 6y. And then I have my 52 here equals 10. And then I solve.
Wait, how did you get 52?
4 times 13 is 52. I distributed 4 times y is 4y. 4 times 13 is 52 plus 2y. Does that make sense? Then I solve. I'm going to subtract 52 from both sides. I swear, if the kids weren't my witness, I would think I was losing my mind.
You're not losing your mind, I promise you.
And I didn't say anything when I went to when I went to wave to you. I didn't tell them what I was doing or say anything about the noise at that point, you know.
And look, I don't hear anything. As soon as I probably go up front, you make sorry again. Because like I said again, when I heard it, I was like, that's the noise. And I was like, well, where is coming from? And I think the doors and the thing off. So I'm like, I don't know.
But like I said, those were two different ones, you know. And that one, that sounds like it, but it's louder and boom, boom, boom. Yeah, but that's the one that sounded like it.
That's why I'm in and out.
You hear it?
That was me hitting the table.
No, that's not what I heard.
Okay.
No, because I heard it from up there. It was just one. Hit it again. Hit the table.
Do it at the same time.
What if this place is like a living
Three,
building
two,
like that one?
one.
Kind of hard, and that's
You see,
I think I just heard
Have
it.
you
Did you
seen that
say
movie
something?
where the kids go to the house, but the house is in the wall?
yeah, but very faint. Everybody be still and don't hit the table.
Now, in a minute, I walk out up front.
I know.
You probably hear it.
I'm gonna run up and I'm gonna
I wish my mic would pick it up, but I have my mic right here, and it doesn't even pick up their voices. It's designed to not pick up background noise.
Everybody don't walk out because
I know. I'm starting to suspect that. Because like after I told Ashley, she said, "Oh, we don't know where it's coming from," or she said, "You know, we're investigating it." And I'm like, "Okay, the music and the pounding, they come at the same time."
you know what?
And then the next week, no music, just pounding.
When I went and he came down and after that. But you know what? I guarantee you, he probably knows with them back and forth, you know, coming out. And he may do it, but just wait here and I'm going and I'm letting him know like I had something on me and I heard something.
Yeah.
Alright,
Yeah.
so why don't you walk out and then I'll come up the stairs.
Yeah, go walk out to where we can see you.
Okay. Okay, crew, let's look it up. So now we divide by 6 and we get y equals -7. -42 divided by 6? Very good. What?
Yeah, you're right.
Okay. So listen up now. So we get y equals -7. What do I ask myself now? When y is -7, in one of these equations, when y is -7, what is x? When y equals -7, what is x? On either one of these equations, this one or this one, I want to know what point has a y coordinate of -7. Let's just draw this. We have x minus y equals 13. X minus y equals 13. Now I can graph this using intercepts. Either x equals 13 or -y equals 13. First I'll block out this one and I get x equals 13. Then I block out this one and I get -y. So y equals -13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, or 13. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So here are the x and y intercepts of this line. So I've graphed x minus y equals 13 right here. Now let's graph 4x plus 2y equals 10. 4x plus 2y equals 10. So we say either 4x equals 10 or 2y equals 10. Divide by 4 and x equals 5/2. Divide by 2 and y equals 5. 1, 2, 3, 4, 5. And 2.5. So here is this equation. This is 4x plus 2y equals 10. Now, here's where they intersect. We know that the y value is -7, but we don't know the x value. So we know this is 1, 2, 3, 4, 5, 6, 7. I don't have my lines quite right. But what is the x value? We can see it's going to be about 1, 2, 3, 4, 5, probably 5 or 6 right there. Okay? But there's only 1 point on this line, and there's only 1 point on this line that has a y coordinate of -7, huh? So let's see what it is. Let's take our first equation, x minus y equals 13. Plug in -7 for y. Now don't look, this is a minus sign, and this is a -7. So x plus 7 equals 13. Subtract 7 from both sides, and we get x equals 6. That makes sense, doesn't it? X equals 6. So, plug your solution into one of the equations and solve for the other variable. So I did steps 1 through 5 and I solved. Then I took this solution and I plugged it into one of my original equations to solve for the other variable.
How'd you get the point all the way down there?
I graphed this line and I graphed this line, and that's where they intersect. What's your question? This is the graph of my second equation, actually. My first equation was this one. My second equation was this one. I graphed these two equations, and I see where they intersect. This is the solution that they have in common. I graphed it using the blockout method. Now let's go to number 8. Maxwell, what's your question?
I don't understand how you graph it.
You don't understand how I graphed this line?
No.
Right here. I found out my x-intercept and my y-intercept using the blockout method.
I see. I thought 5-2 was just one thing.
5 halves is 2 1/2.
I get it now.
Okay. So now everyone try number 8. Say it again. I think that was this. Look. No, that wasn't it. I didn't hear it. I heard that one, yeah. Who says it's freezing?
It feels good. Not cold at all.
And he's got a jacket on. You have fever? Okay, let's work on this one now. Come on. Y'all, get this one done. Let's all get the same variable alone. Let's all get this x alone.
How'd you get the 2x and 8y?
This is number 8. You see number 8? Did I write it wrong? We're on the same page.
Oh, I was looking at something. Come on.
Okay, settle down. So we get x alone. In one equation, we got the variable alone, step 1. That's step 1. Step 2 is to substitute the answer for x in the other equation. So I'm going to write the other equation, and in place of x, I'm going to put my answer to my first equation, that's negative 7y. So in place of x, I'm going to put negative 7y. Does everybody understand that?
Wait, it's negative 7. Yeah.
I don't really need to distribute. I just need to multiply and then collect like terms, huh?
So, I have a question for you. Is it okay if, because tomorrow I might have to leave a little bit earlier, is it okay if I can just get my homework and stuff from you tomorrow, like earlier tomorrow?
Yeah, we're writing our paper.
Oh, yeah.
Did everyone get y equals negative 1? Now, so we didn't need to distribute, we kind of distributed this 2, but we only have one thing in parentheses. We collected our like terms, we solved. Now we're going to do step number 6. So this was step number 2. And then this was step number 3. This was step number 4. This was step number 5. And now we're going to do step number 6. We got y equals negative 1. Now we're going to choose either one of these equations. This one's simpler, so let's choose that one. X plus 7y, I keep wanting to put y, equals 0, and we're going to plug in negative 1 for y. X plus negative 7 equals 0, so we're going to add 7 to both sides, and x equals 7. So 7, remember, x comes first, so 7 and then y, negative 1, that's our solution. 7, negative 1 is a solution to this equation, and 7, negative 1 is a solution to that equation. It's the only solution that they have in common. Yeah, oh yeah, definitely. And remember, it's on the video also. Yes, a short quiz. One of those problems.
You would have to have this. You would have to. So what are we used to do?
Any questions about this? Does everyone have those steps written down? Or take a picture of it. You can also go and watch the video.
So this just applies for this, like 6 and 8. Like problems like that.
This applies to problems that are a system of equations. When they give you two equations and they say, what is the solution to this system of equations? A system of equations is 2 equations or 3 equations. We're just working with 2 equations right now. So a system of equations is 2 equations. And when they say, what is the solution to this system of equations? One way to find it out is through the substitution method, which we just did. This is the substitution method. Does that answer your question? Gabby, does that answer your question? Tell it to me again. I might not have understood your question.
Like you see how 5 it says a y is equal 4x minus 9, but on 6 and 8 it doesn't say that.
Well,
Like it's different.
yeah. Okay. So taking a look at number 5, do you have to get a variable alone? No, a variable's already alone. You see that?
Yeah.
So then you're just going to go to step 2 because you don't have to get a variable alone in one equation. You already have a variable alone right here. Now, you would go to this equation and instead of y, you'd put -5.
Okay.
Does that make sense?
Yeah.
Okay. Look at question number 5. Step 1 is already done. A variable is already alone. Everyone has these? Now the next method, there are 2 methods. Well, there are 3. Graphing is one of the methods. But graphing is not exact unless you're using a computer or something. Mr. Jesse, stop playing around. Okay, so now let's turn to page 372. And let's take a look at number 1. Now, first of all, let's go over to this side of the board. It's almost dry. We know that 3 plus 5 equals 8. We know that's true, don't we? Right? -2 plus 7 equals 5, doesn't it?
You didn't hear nothing? Oh, because on the end they are banding. I guess something going on. They put a sign and stuff, so I don't know if that's what it is, but they are outside.
Yeah, I'm not having any. Has anybody? We heard it once about 5 minutes ago.
Yeah.
Twice.
Twice?
About 5 minutes ago. Just one time each time, but that was it.
Okay. Well, just let me know.
Okay. Thanks.
All right. It was slow.
Yeah. So we know that this is true, and we know that this is true. Sullivan, you have to look here. We know that this is true, and we know that this is true. So what happens if I add these, and I add these? 3 and -2 is 1. 5 and 7 is +12. And 8 and 5 is 13. It gives me a true equation, doesn't it? That's the concept we use to use the elimination method. Now remember, the only way to solve a system of equations is to get it down to one variable. Solve for that one variable. I can't solve when I have 2 variables. There's an unlimited number of solutions. So what I'm going to do is, you see when I add -4x and +4x, That eliminates x, doesn't it? That's why this is called the elimination method. Elimination method. Negative 4x plus 4x is just 0, nothing. Negative 2y plus 8y is 6y. And negative 12 and negative 24 is negative 36. Now, I know this is true, don't I? Because I'm telling you this is true, and I'm telling you this is true. So if this is true and this is true, when I add them up, it gives me a true statement every time, doesn't it? But now I only have one variable, don't I? I can solve for one variable, divide both sides by 6, and I get y equals negative 6. What, Sullivan?
I know where we are.
Now, I'm going to go back to either one of my first equations. Which one should I use, Gabby? This one or this one? It doesn't matter. Pick one.
Negative 12.
Say it again. This one, the first one. I'm going to take negative 4x minus 2y equals negative 12. And I'm going to say, when y is negative 6, what is x? When y is negative 6, what is x? I'm going to plug in negative 6 for y. Now I'm going to solve for x. Just like we did in the substitution method. Now remember, x comes first, so our solution to this system of equations, the point where these two lines intersect, is 6 for x and negative 6 for y. If I plug in 6 here and negative 6 here, this is true. And if I plug in 6 here and negative 6 here, this is true. This is the only point where they intersect because they're two straight lines. So they can only intersect in one point, huh?
That's pretty cool.
Isn't it? Now I want everyone to try number 2. Solomon, did you get that answer?
Yes, no, I did.
Very good, very good. Now, Sullivan, which equation should I choose to plug -1 for y into? It doesn't matter. Either one will give me the same answer, huh? So, because when y is -1 here, whatever x is going to be the same thing here when y is -1. So you want to take the first one? Let's take the first one.
So it doesn't.
Doesn't matter which one you choose. Does this make sense, Miss Ashlyn? Very good, very good. Well, the other things have just been the tools. Now we're starting to use the tools that you've learned to actually do something. When you get to calculus, this is still yet another tool, actually, but you can see a little bit more. But when you get to calculus, you use all of these tools, and then it makes perfect sense. Huh? Not yet. I do not know calculus.
Miss Laura, are you allowed? No.
Go ahead, ask me.
I know you have to be 17, but can you, like, take the ASVAB here, or do you have to take it? Like, can you take it here?
Like with me?
Yeah.
No. I think they either use a testing center or a testing company, or they give, or the armed services give that themselves. It's a test to get into the military.
Oh yeah, no, you have to.
I just wanted to take it just so I could see, like, my options.
You have to go to your
Got to know Algebra I for that. Kylie's brother came to me for some tutoring for that. Yeah.
You have to go into your wherever your recruiter is.
Okay, did everyone get this answer? Now, notice that when we added these two, one of the variables canceled. It doesn't matter if x cancels or y cancels, but one of them has to cancel to make this work, doesn't it? Otherwise, I just get an equation with two variables. So now, let's take a look at number 7. We're still on page 372. Haven't been writing the number. Number 7. We have -6x plus 6y equals 6, and -6x plus 3y equals -12. If I add these two together, will one of them cancel, Ashlyn? No. One won't cancel. What do you think I can do to make one cancel? Well, if this were a +6, that would make it cancel, right? How can I make that a +6? I can multiply it by a -1, can't I? But I can't just randomly multiply by a -1. But remember, I can if I do it to both sides of the equation. If I multiply this side of the equation by -1, and I multiply this side of the equation by -1, As long as I do it to both sides of the equation, I haven't changed the equation, have I? I mean, I've changed it a little bit, but it still has the same x and y values. So now I'm going to say negative 1 times negative 6x is 6x. Negative 1 times 3y is negative 3y. And negative 1 times negative 12 is positive 12.
So this is a different thing than that?
This is the same thing, but first, you see here, these already canceled. But now I have to change this. Now, so now instead of this one, I have this one, right? So now I have negative 6x plus 6y equals 6. That's my first one. And instead of my second one, now I have 6x minus 3y equals 12. Now will they cancel? Mr. Jesse? You're going to have to know this, bud. Will they cancel now? What will cancel? Okay, you're just completely tuned out, bud. What will cancel, Sullivan? 6. Exactly. Negative 6x and 6x. These will cancel. Because remember, I have to have one of them cancel if I'm going to be able to solve it. Negative 6x and 6x is 0. 6y and negative 3y is 3y. And 6 and 12 is 18. Kate, does this make sense? Very good. Y equals 6. What do I do next, Kate? Which one? Now look right here. I can use this one. I can use this original one, or I can use this one. It doesn't matter. I can use any 3 of these. Because this xy, and this xy are all the same x and y values. Which one would you choose, Kate? Okay. So we're going to take this one, 6x minus 3y equals 12. We're going to plug in 6 for y. And then we're going to solve for x. Negative 3 times 6 is negative 18. Now we're going to add 18 to both sides. 6x equals 30. Then we're going to divide by 6 and get x equals 5. Now look, don't make the mistake of putting 6, 5. Maxwell, don't make the mistake of putting 6, 5. X is 5, it comes first. Let me put it up here. X is 5, it comes first, and then y is 6, it comes second. This is the solution to this system of equations, and this one too, actually, you know. But this is our original problem right here. This solution will make this true if I plug it in for x and y. And if I take this solution and plug it in for x and y here, it will also make that one true. It will also be true. So we've solved that system of equations. Now everyone try number 8. Remember, you have to multiply both sides of one of your equations by -1 so that you have one variable that eliminates or cancels out. How's he going to pay attention? Mr. Jesse, are you doing it? His what? His, oh, that. I need to buy stock in the paper towel company. I need to buy stock in the paper towel company. So, are y'all going to come and help me? And you're going to help me, right? With tie-dyeing? Thursday, 1 to 4. Your mother already put it on your calendar. Hey, Miss Diane. No, she knows you're coming. She and I texted, and she told me she was going to buy you a T-shirt so that you could make her a Mother's Day present. Tie-dyeing. You going to come? Oh, you were asking? I sent an email home, Jesse. Is that you that was asking me, Jesse? I sent an email home, and this Thursday from 1 to 4, we're going to be tie-dyeing. So we're having a tie-dye party at my house. Let me know if you're coming. Austin, Sullivan, and Maxwell, huh?
You going to? Yeah, buddy. So, what? I might be going. Gabe's coming too. I might. So is Kate. So is Brett.
I might.
You are obligated. You are.
Bruh, I'm not busy. Thursday.
It'll be fun.
Wait, it's 2 days from now.
Yes, day after tomorrow, 1 to 4. There you go. There you go. And if you don't have a ride, I might be able to pick you up. Let me know. Okay, is everyone working on number 8? Jesse, do you have number 8 done?
Do we have the
Matthew, what did you do to make one of them cancel? Because this will give me 15x and this will give me 4y.
I divided,
Multiplied?
-1 by both sides.
Of which equation?
Bottom equation.
On this one, you could do either one. You multiplied the second one by -1. By -1. Okay. Now remember, that just changes the signs of everything. I don't really have to go through and distribute. I just need to change the signs of everything. When you multiply by -1, it just changes the sign of each term. So positive 8x becomes negative 8x. Positive 2y becomes negative 2y. And positive 30 becomes negative 30. Now I'm going to go ahead and put this one back on top of this one. It can be underneath or on top of it, doesn't matter. Now, this will cancel, won't it? This gives me negative 1x. This is 0. This gives me negative 6. Now, again, I multiply both sides by negative 1 because I don't want to know what negative x equals. I want to know what x equals. Negative 1 times negative x equals x. Negative 1 times negative 6 equals 6. Which equation did you choose to plug it into? This one, or this one? The first one, the second one, or this one?
The first one.
So you took 7x plus 2y equals 24. You plugged in 6 for x. So you took your first equation, and in place of x, you put 6 because we got x equals 6 here.
Wait, I'm confused.
Okay. Tell me what's confusing you.
That, like, negative 1, that right there.
Well, what I have, did you get negative x equals negative 6? Did you get that?
I did all of, like, what's it called? I did all of this. Like, I got, like, what's it called? I did all of this, but I erased it. Like, I didn't understand how you got that.
What is 7 plus negative 8x? Negative x, right?
Oh.
And positive 2y and negative 2y is just nothing. 24 and negative 30 equals negative 6. Put your equal sign. Now, I don't want to know what negative x equals. I want to know what x equals. So I have to multiply both sides by negative 1. So I find out that what positive x equals.
Oh.
Does that make sense?
Yeah, I just didn't have, like, know how, like, you said negative 1. But now I do.
Very good. Then I plugged in 6 for x right here. And now I'm solving. 48 minus 42 is 6. Any questions about this?
How much longer do we have break?
With 17 more minutes of class. No, because I have one more thing I need to show y'all. This is on the ACT almost every single time.
This is or what you want to show us?
This is. Does everyone have this down? Now, there's another complication when things don't match. We're still going to do elimination method. But let's take a look at number 9. This is page 372, number 9. We have 5x plus y equals 9. And 10x minus 7y equals negative 18. Do either one of these cancel? Do either one of the variables cancel? If I add these two, I get 15x. If I add these two, I get negative 6y. neither one cancels. If this were a negative 10, that would cancel. Or if this were a positive 7, that would cancel. Let's make this one a negative 10. What can I do to both sides of this equation, Kate, to make this 5x a negative 10x? That's exactly right. But I have to multiply both sides by negative 2, don't I? Negative 2 times 5x is negative 10x. Negative 2 times y is negative 2y. And negative 2 times 9 is negative 18. Now, so I've redone this one. Now I'm going to write this one underneath. 10x minus 7y equals negative 18. Now, when I add them, now one of them will cancel, won't it? Right? This is nothing. Negative 10x plus 10x, 0, nothing. Negative 2y and negative 7y is negative 9y. And negative 18 and negative 18 is negative 36. Now I divide both sides by negative 9 to get y alone. And 4 times 9. So y equals 4. 36 divided by 9 is 4. Both two negatives make a positive. Now, Kate, what am I going to do to find x? For which equation? Huh? The second one? 10x minus 7y equals negative 18. Now I'm going to plug in 4 for y here. 10x minus 7 times 4. Instead of y, I put 4. 10x minus 28 equals negative 18. Now I'm going to get x alone, so I'm going to add 28 to both sides because I want to get x alone. That leaves me with 10x equals positive 10. Then I'm going to divide both sides by 10 to get x alone. X equals 1. Kate, what is my solution to this system of equations? X is 1. Very good, Kate. Y is 4. Now I want everyone to try number 11. Yes.
I don't see how this would work.
So remember how I had to multiply everything by 2y to get 10 from 5?
Okay, but what I'm saying is the 16 would cancel out and equal
No, it wouldn't.
everything left
It
on
would
the
not.
side.
Take the top one, Sullivan, and multiply everything by negative 3. Because you need to cancel out 1 and negative 3 plus times negative 3 is positive 9. I'll cancel out because it's a negative 9 is positive.
Oh.
First time I saw it explained it.
Let's see both these for a second. Trying to figure it out.
Sullivan, take a look at number 11. For the x coordinates, one's -3 and one's -9. I need for them to match. How can I make them match? But I need the signs to be different. But first, let's talk about them matching. How can I make them match? Can I turn that 3 into a 9? I can multiply it by 3 and make it 9, right? But I need for it to be a positive 9, don't I? That's right. That's right. Right, you have to multiply everything on both sides of the equation. In that equation, you have to multiply both sides of that equation by -3. Is that what you got when you did it?
Yes, ma'am.
Very good. Now I'm going to rewrite the second one underneath it. I have one more thing to show you, so finish this up and let me know if you have any questions. Let me know if you didn't get that answer. Yes. Thank you. Thank you. You gonna bring Truman? Wyatt is probably old enough to do it too. Any questions about this? Now, let's do one more type, the last type. Let's go to page 373. And let's take a look at number 17. We have negative 7x minus 8y equals 9. and negative 4x plus 9y equals negative 22. Gabe, did it cancel?
Yes.
Which two cancel? Negative 7 and negative 4, that equals negative 11x when I add it up. Negative 8 and positive 9y, negative 8y and positive 9y equal positive y when I add it up. Neither one of them cancels to 0, does it? Now, if I multiply this by 2, well, then it becomes 8. That won't work, will it? What if I multiply this one by 2? Well, that becomes 16. That won't work. So I've got to change both of them. Let's take a look at the x's. If I multiply negative 7x by 4, what does it become? Negative 28. If I multiply negative 4x by negative 7, what does it become? Positive 28. Multiplying both sides of this one by 4 will make this negative 28, and multiplying both sides of this one by negative 7 will make this a positive 28. Does that make sense? So I've got to multiply both of them. 4 times negative 7x is negative 28x. 4 times negative 8y is negative 32y. And 4 times 9 is 36. Now I'm going to do my second one. Negative 7 times negative 4x is positive 28x. Negative 7 times positive 9 is negative 63y. And then negative 7 times negative 22, 7 times 2 is 14, and 154. Put this over here. Now they cancel. But I had to multiply. Stay tuned in here. Stay tuned in here. I had to multiply both of them. Kate, does that make sense? Now you see this one cancels. So these just cancel out. Negative 32 and negative 63 is negative 95y. And then 36 and 154 is 190. Now if I divide both sides by negative 95, I get y equals negative 2. What do I do next, Ashlyn? Tune in right here. Oh, it's okay. Come. Yeah.
Okay. I'm at the end if you need me because I need attention. It needs attention down here.
Okay. I can use either this equation, or this one, or this one. I plug in negative 2 for y. Let's use this one, looks the simplest. Negative 4x plus 9y equals 22, that original one. And I'm going to plug in negative 2 for y. I usually try to take the simplest equation, but like I said, it doesn't matter. Negative 4x plus negative 18 equals 22. So I'm going to add 18 to both sides. I get negative 4x equals 40. Then I divide by negative 4 because I want to get x alone. X equals negative 10. Cash, what's my solution to this system of equations?
Negative 10 and 2.
Very good. Negative 10 and negative 2, right? Remember, the x comes first. Okay, hello. Okay, let's try one on your own. Hold on, that was number 17. Try number 18. Number 18. Is today the 25th? Sullivan, what solution did you get?
I just went down to the bottom. I got y equals negative 33.
You got what?
Y equals negative 32, but then I have to break it down further.
Did anybody else get y equals negative 33?
Negative 33.
I've never get anything to cancel.
Stay quiet and let's tune in up here. Matthew, what are you going to do to make them cancel?
Gotta multiply each one by 5. Well, top one by 3 and the bottom by 5.
But then that will give me a positive and a positive 15 and a positive 15. So you have to make one negative.
Okay.
Which one you want to make negative?
Negative 3.
Negative 3.
Okay, I was doing it right.
Sullivan, did you get this?
I forgot to put negative 15. Oh no, never mind. I see where I messed up.
Let me show you one last thing. Look at number 23 on page 373, number 23. Your x's have to be over your x's, your y's have to be over your y's, and your constants, they have to be in the same order. Now this one is a constant first, the equal sign, and then y and then x. I can put this one in this order. Here's my constant, so let's subtract 10y from both sides for this one. That gives me 4 equals, I want my y first and then my x, so negative 10y plus 2x. Because that wouldn't help. That still wouldn't put them in the same order if you flip them. No, because here I have a constant, here I have a y and an x, here I have a y and a constant and an x on the other side. You see the y and the x are on the same side of the equal sign. Now I'm going to rewrite this one. Negative 14 equals negative 20y minus 7x. I rewrote the first one. Now I'm going to write the second one. 4 equals negative 10y plus 2x. And you can do it like this, or you can flip them both. But they have to be in the same order to be able to solve the system of equations. So next week, I'm going to tell you what's going to be on your final exam. Then we're going to cover a little bit more material. Then you will be on your, you'll have to schedule with me 368 to 376. You need to be able to pass your final exam to be able to go to the next math.
What's the passing grade for exam?
I'm sorry, what?
So what's the passing grade for exam?
70. If you get a 70, I mean, you pass, but to have mastered Algebra I, you really should get about an 85, a minimum of an 85. That's it.
What's the OSCS?
The what?
I was about to ask you.
So, do you want these pages back?
Oh, yes, please. Hello, hello. Thank you very much.
Yeah, your mom.
Miss.
My dad said he's gonna get it tomorrow, like bring it here tomorrow because what's it called? My grandpa Steve, he just came in today, like from out of town.
Gotcha. Okay.
That's extra pages that they gave me.
I gave you extra ones?
Yeah, like it was like I had those, but I had like another page too.
Okay. Strange.
Would those possibly be the reason why I missed?
What?
I don't know.
Cute shirt, Katie. Cute shirt. They should be. What papers are you looking